Good afternoon. So for today's video, I'm going to look at the important map skills to answer question 3. Remember, my TikTok account, it focuses mainly on mapwork skills, especially part of section B, be it grade 10, 11 or 12. So my main focus is on mapwork skills. So today I'm going to look at the important map skills to answer question 3. But the assumption that I'll be carrying when I'll be doing this video is you know basic map interpretation. That is number 1. You know how to do all the calculations in as far as mapwork is concerned. That is number 2. So I'll be basing on those assumptions that I'm talking to people who already know how to do map interpretation, how to do the calculations, and how to do everything that is included in as far as section B is concerned. So the first thing that I'm going to talk about is height. You are able to do this map skills in order to answer question 3. So the first thing that I'm going to talk about is height. Okay, how is height shown on a map, or how can you be in a position to know the height, be it of landforms, given features, and so on and so on. So when it comes to height, the first thing that you're supposed to look at is your contours. That is the first thing that you're supposed to look at when you want to consider the height, be it of a feature or a landscape or the topography on a map. Then the second thing that you can also take into consideration when you want to check your height is your trig stations. That's another thing that you can also take into consideration when you want to check the height on a map of features, topography, or the landscape. The next thing that you can also check off in as far as height is concerned is your spot height. And lastly, you do your benchmark. That will be your benchmark. So the first thing when it comes to height, of course you need to know the height of landforms. It can be height of features, it can be height of the topography as indicated on the map according to the question paper, according to what you are being asked to do. So when it comes to height, these are the 4 things that you look at. You look at your contours, you look at your trig stations, you look at your spot height, you also look at your benchmarks. Okay, when you're talking about contours, obviously they show height above sea level on a map. You can see if maybe it's a topographical map. Let's assume that here our contour height is 100 meters. You know, the contour interval of our topographical map is 20 meters. I'm just assuming, I'm just working on that one, 980 meters. Obviously, we are saying that when it comes to height, if you want to identify or to find the height in as far as the question that you're being asked to tackle is concerned, the first thing that to make reference to is your contours. Obviously, on your map, you'll have contours, which will be showing the different contour heights. Then the second thing is your trig station. Your trig station is written like this. You have a triangle, then you've got your height here at the bottom, then you have something like this. So when you're looking at your trig station, trigonometrical beacon or trig station, it will be like this. You've got your triangle. This one is your beacon number. And this one, it shows your height. So these are the 2 things that you find on your trig station. There is your beacon number, there is your height. So please make sure whenever you are answering a question that has to do with height and you are asked to identify the height using the trig station, you're supposed to know that there are 2 numbers that are shown on a trig station. You've got your beacon number, then you've got your height. You should always check your height. Obviously, it is at the bottom of the triangle. Then you've got your beacon number. Usually, it is on the side of the triangle. That is your beacon number. And this one is your, beacon number. That is your beacon number. This is your beacon number, and that is your height. So you've got 2 things. They can refer to, say, trig station 313. So when you are given 2 heights, let's say trig station 313 and spot height, I'm going to give you an example of a spot height, 1132. This is your spot height. This is your what? Your spot height. This is your spot height. spot height 1132. You can see the way a spot height is shown. This is your trick station. This is your contours. It's your contour line. Okay, so they can say trick station 313, which is the beacon number. So most of you end up using the beacon number as the height, which is wrong. Okay, so normally they give you the trick station 313, which is the beacon number, and spot height 1132. So whenever you're calculating, let's say gradient, you're supposed to take into consideration the two height. This is this one and this one. You do not use the 313 because it's a beacon number. You cannot use 313 because it's a beacon number. You're supposed to take note of that. So this is what you should know. And as far as height is concerned, your contours I've demonstrated. Your trick station, I've shown you that on a trick station or trigonometrical beacon, you've got your beacon number and your height. Then also on your spot height, of course, there's a spot here. Then you've got your number which shows the height. Okay, that's a spot height. Then lastly, we have got what we call a benchmark. Benchmark usually is shown along the road. Let's assume that this is N11. Let's assume that is N11. There can be an arrow, then 1, 1, 0, 3. This is what we call a benchmark. A benchmark usually is marked on the road. Okay, the arrow is pointing towards the road. So this will be your benchmark. This will be your what? Your benchmark. So we have got a benchmark. Of course, it has got height, and then the arrow that is pointing towards the road. Then you've got your spot height here. You've got your trick beacon or trick station, which has got the beacon number and the height. Then you've got your contours. So in as far as the height is concerned, we are basically saying that there are three things that can help you to interpret height on a map. That is your contours, your trick station, your spot height, and your benchmark. Just to be specific on that one, contours obviously on a line. I'm taking this as an example of from a topographical map. We just got an contour interval of 20 meters. Then you've got your trick station. That is your trick station. Of course, then you've got your spot height, then you've got your benchmark. So these are the three things that can help you to interpret height on a map. That is your contours, your trick station, your spot height, and your benchmark. These are the things that can actually help you to interpret height on a map. The next thing that I'm going to talk about that you're supposed to know as well is your map reference. Okay, when you talk about map reference now, okay, remember what we said, that the maps in South Africa, how they do them, this is a grid, of course. The grid, or before we do that, okay, let me just give two examples of our latitude, okay. Let me say I've got 30 degrees here, then I've got 21 degrees. Obviously, this is east and this is south. So what you are going to do is whenever they're doing maps, they do under map referencing, they divide the grid into 4 bigger blocks. That is, they do like this. That is your A, B, C, and D. That's what they do first. They divide the whole grid into 4 bigger blocks. I'm going to further divide each block into 4 blocks so that I have from the whole grid, I'm going to have 16. Okay, so I'm going to do like this. Okay, which means this one becomes A, B, C, and D. 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 So I have this now. When I'm looking at this map, of course, I'm gonna write the map code or the map reference of this map. Of course, I'll start with the latitude, which is 30, as given there. Then the longitude 21. Then let's say I want to write maybe this one, so I will have D. So when I'm looking at this map, my latitude is what? 30 degrees. My longitude is 21 degrees. The bigger block is referred to the map is what? D, which is A, B, C, D, which means I'm talking about this. Okay, then the smaller block, this one is the bigger block. This one is the what? Smaller block. Remember, whenever you look at your map, it tells you that it's an extract of, which means this map that is 2031 DD was taken from this whole map, which means 3021 DD is an extract. Of course, that was taken from this map. You understand? You understand? So from this whole map that has got latitude 30 and 20, we are only looking, or we have only a 2030 DD shown, which is this part. This is what is shown on your map. So this is an extract that was taken from this whole block. So we have got 3021 DD, which is an extract. Okay, this is an extract, which means it was taken from a bigger map. So this is only what we are looking at, which is 30, that is your latitude. 21, that is your what? Your longitude. So this is what it is when it comes to map referencing. Remember, I'm just trying to make it as I'll try to make it as bold as possible. This is your A, this is your B, this is your C, this is your D. So this is map referencing. This is map referencing. So we are saying now the map or the grid is divided into 4 bigger blocks, that is A, B, C, D. It is further divided into 4 bigger blocks per each block, which is A, B, C, D, B, A, B, C, D, C, A, B, C, D, D, A, B, C, D. So when you're having your map now, reference is 3021 DD. This is what is shown here now. Okay? 3021 DD. Which means this map is only showing this. Out of this, it's only showing this. That's what it means. That's why it's written as an extract of. So 3021 DD, this is the latitude. The first, this is the latitude. The second, this is the longitude. This refers to the bigger block. This refers to the smaller block. So you're supposed to know that. You can have a question that says, what is the map, let me say, east of, let me say, west. Okay, what is the map? Let me say, start with west. West of 2031. Okay, so we are saying west of 3021 DD. So where is DD? 3021 DD is here. So west is on your left, which means the answer there will be 3021 DC. If it says north of 2031 DD, you come where you've got your DDs here. Which map is north now? Is going to give you 3021 DB. If they say northwest of 2031 DD, northwest, which means it's here, which means you're going to have your 3021 DA. That's how it works. You're going to have that, okay, DA. That's how you get your answer when it comes to map referencing. So you're supposed to know how to do this map referencing. It's something that is very important in order for you to get all the marks for question 3. Okay. The next thing that I'm going to talk about is the grid reference. Normally, I know when you hear the word grid reference, some of you think of it as being in alphanumeric. That is your alphabet first, then your number, next like A4, okay, like maybe C5 or D6. Of course, that's part of grid reference. But when you talk about grid reference at this level, we also include the coordinates. We also include what? The coordinates. We also include the coordinates, which is what? Which is also what we call geo-referenced. Okay. So what we are saying now is when it comes now to grid reference, of course, you know, on your map, they can say you refer to block D3. Of course, according to the way we do it in an alphanumeric, that is, we start with the alphabet first and the number. That's where we talk about D3, C5, A4. That's also part of grid reference. But normally when you talk about grid reference at this level of FET, we are talking about the coordinates, which means when you look on your map now, we are now saying that, let's say I'm just giving this as an example, assuming that you are aware of this. Okay, 33 degrees, 22, okay, 22 minutes, 18 seconds south, okay? And obviously it's supposed to be in terms of latitude and longitude, 18 degrees, 34 minutes, 42 seconds east. So when it comes now to your coordinates or your grid reference, you're supposed to know how to write the coordinates or how to georeference the coordinates of features or places. So you're supposed to know that you start first with your latitude. You start first with your latitude. Then you finish off with your longitude. That's how you do it. So latitude first, then you've got what you call what? Longitude last. So you always start with your latitude, then your longitude, which means your degrees, minutes, and seconds. Make sure also that you show the degree. This is the sign for your minute, okay? This is the sign for your minute, this is the sign for your second. You're supposed to make sure that you indicate that, and also the hemisphere, which is S there for south. So you've got the degree, the minutes, the seconds, then you've got the hemisphere. Why are we only considering S and E? Because South Africa is in the southern and eastern hemisphere. So we consider south and east, but you always start with your latitude, then your longitude. So make sure that you write your degrees, sign there, minutes, sign there, second sign there, then the hemisphere. So you've got your degrees, okay, then you've got your minutes, then you've got your seconds, then you also have your hemisphere. Okay, that's how you're supposed to do it when it comes to grid reference. I think I'll move on to the next concept. Okay. So the next thing, when you are doing your cross section, obviously you need to be able to know that this is more like a side view. Of course, the topography from one point to another, let's say from A to B. We have got something like this, A here, then it goes up, then it goes to the point B. This is part of the landscape from A to B. So you're doing more like a side view. This is a cross-section of view from A to B. So you should be able to do your cross-section. How do you go about it? Obviously, you make use of contours. Where it starts, maybe it's a lower land. As it goes up, then it goes down again. You can also have another one where maybe it starts maybe from a higher position, then it goes up again. Okay, so it means you have got A and B. All these are cross sections. So when you're doing cross section, obviously you are looking at the height of features along, okay, along the points that you have been asked to draw as a cross section. Let's say from here up to there, these are the lands. This is the landscape from A to B. Obviously, you find that it starts off here from a lower land, it goes up, then it goes down. Here it starts off from a higher ground, then it goes up, then it goes up again. So this is more or less what your cross section is all about. So you should be able to come up with just a simple cross section which shows like a side view from two given points, from the first one up to where it ends. You should take note of where you are asked to start with and where you are asked also to end with. So that marks or what more or less what the cross section is all about. Remember, I'm doing it with the assumption that you already know how to do the cross section. If you do not know, please, I refer you to some of the videos on my TikTok account, and also I can also refer you to my YouTube channel on my bio. You can just check there. There's a lesson about cross section, lesson about intervisibility as well. So when we are talking about the next concept, that is intervisibility, we are now saying that when you are standing at A, are you able to see clearly B without any obstruction? That's what intervisibility is all about. So if I'm to take the first one into consideration, you cannot see A, B from A, which means what? There is no intervisibility. That's what it means. Okay, you cannot see B from A. Why? Because there's an obstruction here. You cannot see. Okay, there is an obstruction, so there is no intervisibility. But from here, if I'm at A here, and there is where my B is, I'm able to see B, there is intervisibility. I'm able to see A from B or B from A, there is intervisibility. There are no obstruction between these two given points. So that's what it's all about. You're supposed also to know how to do your intervisibility. Of course, your cross-section and your intervisibility, it works hand in glove with your vertical exaggeration. Okay, we'll talk about that later. But if you want to know how to calculate your VE or your vertical exaggeration, I can also refer you to my YouTube channel. I think you can see it. It's also on the link is on the bio. You can also check some of the videos that are on my TikTok account. It's there. Okay. So the other thing that you're supposed to know that is important in as far as number 3 is concerned is direction of the river flow. When we talk about the direction of a river flow now, we are now saying now, how do you determine the direction in which the river is flowing? Okay, number 1 is you have to make use of your height. Just check your height. Okay. Why am I saying height? Because obviously when a river is flowing, I'm gonna do like a profile of a river. Of course, it goes like this, okay? The profile, the longitudinal profile of a river. Remember, here is what we call the upper course. This one is the middle course. This one is the lower course. Okay. So when you're looking at the profile of a river, you have got the upper course, okay, where the river starts. This is what we refer to as the source. Where the river ends, this is what we refer to as the mouth, okay? This is the mouth where it ends, this is the source where it starts. So normally, our river starts from the source, which is an upland, okay? Which is, of course, let me just say highland, okay? Or upland, whichever way you say it. Okay, let's say the top of a mountain, of course, then it goes down towards the mouth, which is the lower land. So this is the highland or the upland or the source where it starts. Obviously, it's higher in terms of height. I'm saying in terms of height, if you check your contour lines, if you check your spot height, if you check your trig station, if you check even your benchmark, it tells you that this is a higher land and this is a lower land. So by making use of your height, you are able to determine the direction in which the river is flowing. If where it's starting it's a higher land and where it's heading towards the lower land, you know that it's flowing in this direction. I'm just saying it in relation to how you can be able to identify your upper course, your middle course, and also your lower course. But obviously the river starts from a higher land and it flows towards the lower land due to the force of gravity. That's what it does. So that's number 1. Number 2, assuming that this is your river, you can also check at the angle at which the tributaries, that is the small rivers, join the main river. This is the what? Main river, okay? This is the main river. Sorry about the handwriting there. These are tributaries. These are tributaries, okay? These are tributaries, which are small rivers, okay? So they are joining this main river at acute angle. Look at the angle at which they are joining the main river. It can also help you to know the direction in which the river is flowing. In this instance, the river is flowing towards the east because of the angle at which these tributaries or small streams are joining the main stream. So that's another way also you can be able to determine the direction of river flow. That's another way you can be able to determine the direction of river flow. Then the other way that you can also be able to determine the river flow, you look at your dam. This is your dam. So the river will flow towards the dam wall. This is the dam wall. This is the dam wall. Okay. So the river will flow towards the dam wall. So you can check the direction in which the river is flowing by looking at this direction. The river will flow towards the dam wall. This is the dam wall. This is the dam wall, which means the river is flowing towards the east. So you can also use that to find the direction in which the river is flowing. So we have said that you make use of your height. It flows from a higher land towards the lower land, which means you have your upper course where you have got the highest height in terms of your contour, of course, and it flows towards the lower land. Number 2, we have talked about the angle at which the small tributaries are joining the main river. It also helps you to know the direction in which the river is flowing. Then lastly, we look at the dam wall. This is your dam wall, which means the river will flow towards the dam wall. This will also help you to know the direction in which the river is flowing. In some instances, you can also the way in which the name of the river is written. If you can check, maybe it's a river like this, then the right orange river. That's another way that you can also know the direction in which the river is flowing. But the most one, you have to make sure that you try all the different ways to determine the direction in which the river is flowing. You check your height, check your tributaries, check the higher land, the lower land, check the direction. Of course, the river will also will flow towards the dam wall. Then also how the name of the river is written. It can also help you in knowing the direction in which the river is flowing. Then another important skill that you need to answer question 3, another important skill that you need to answer question 3 is your direction and your bearing. When you talk about direction, obviously, we are talking about your cardinal points. That's the first thing. Of course, we are talking about the cardinal points. That is the first thing that you need to know. Of course, when you talk about your cardinal points, we do not end. This is the 4 cardinal points: north, south, west, east. Of course, we can develop it to 8 cardinal points. This becomes your northeast. This becomes your what? Southeast. This becomes your southwest. This becomes your northwest. We can further divide it. Okay, we can further divide it, which means here it becomes north, northeast. This one becomes what? South, south, west. Of course, we can further divide it. Okay, this one becomes your east, north, east. Okay, this one becomes your west, south, west. Of course, further dividing it, this one becomes your north, northwest. This one becomes your south, southeast. Further dividing, west, north, west, east, south, east, of course. So you have now your 16 cardinal points, but this 16 cardinal points was developed from a 4, north, south, west, east, to 8, northeast, southwest, northwest, southeast, to 16. So you should know your 4, your 8, and your 16 cardinal point. You should know that. You need to know your 4, your 8, and your 16 cardinal point. Okay? You need to know your 4, 8, 16 cardinal points. It's very important when it comes to direction as well. You're supposed to know your 4, 8, and your 16 cardinal points. It's very important. The other thing that you need to know as well is whenever we are talking about maybe this direction, normally they ask you direction from a fixed point. So from your question, check the word from and to. That's how you'll be able to determine the direction. Let's say in which the river is flowing, or let's say from one feature to another. So normally we do your cardinal points from the feature that they refer to as from. Then you connect it with the to point. Let's say we have got A here, then you have got B here. What is the direction of A from B? Which means you go where your B is. Okay, your cardinal points. I'm just going to do the 4, of course. Okay, so the next thing that you do, let's assume your A is here. So the next thing that you do is you go to B where it says from, your cardinal points, be it 8, be it 16, or 4. Then after that, you connect the 2 points, which means your fixed point is B. Your fixed point is B. What is the direction of A from B? A from B, which means now you look at is between south and west, which is southwest. Of course, that would be your answer. Or if you want to answer in relation maybe to the 16 cardinal points, it can be west, south, west, or it can be south, south, east, west, depending with the position of your 2 point. So from, that's where you plot your cardinal points. Then you join the 2 point from a fixed point. Then you are able to know the direction from a given point. That's how you do it in as far as direction is concerned. So we are saying now there's direction from a fixed point. You go where it says from. Then you connect it with the 2 point. Direction of A from B. This is B, okay? B is the from, then A is the to. So you go to B, do your 8 cardinal points, then you connect the 2 points. That's how you find the direction from a fixed point. So you have got to make use of the 2 words from and to, from and to, from and to. From, that's where you do your cardinal points, then to, which means you connect the 2 points, then you find out the direction from that fixed point. Then the other thing that you are supposed to have, the other skill that you're supposed to have is when it comes now to your bearing, starting from your true bearing to your magnetic declination, okay, magnetic declination, okay, declination, to your magnetic bearing. So these are the 3 calculations that you will do. These are the 3 calculations that you will do. That is, you will do your true bearing. You will do your true bearing. Remember, it's measured in a clockwise direction, assuming this is where our B is, this is where our A is. So it means you measure it from point B in a clockwise direction. Of course, you join the 2 points. You are measuring in a clockwise direction from the what? From the true north. That's how you do it. So you're supposed to know how to do the calculation in terms of direction. I've explained. In terms of your magnetic bearing, I've just said that. You calculate in a clockwise direction. It means from here up to there. That is the angle that you'll be calculating from here up to there. Okay, magnetic declination, of course, it changes every year. You've got information that is on your map. Remember, I'm assuming that you already know this. So the first thing, note, you calculate the magnetic declination for the current year. How do you go about it? This year is 2025. What year is shown on your map? Maybe it's 2001, which means your difference in years, that is your 2025 minus 2001, you find your difference in years. Then you get to find your mean annual change there. Of course, you calculate up until you've got everything. I'm not going to get deep into that. For reference to how you do your magnetic declination, magnetic bearing, and true bearing, I can refer you to some of the videos on my TikTok account or to my YouTube channel. You can check on my bio. You get everything there. So basically, you should know how to do your true bearing, magnetic declination, and your magnetic bearing. So just to conclude and emphasize some of this stuff that I've been saying just now. So what I'm trying to say is, guys, it's possible for you to totalize mapwork. It's very possible for you to totalize mapwork, but there are certain skills that you need to acquire. That's basically what I'm saying, where I've said that the first thing when it comes to height, know how to determine your height using your contours, using your trig stations, using your spot height and benchmarks. So whenever you're calculating your height, you should make use that you make sure that you make reference to your contour height, to your trig station height, to your spot heights, and to your benchmarks. That's how you're supposed to do it. And when it comes to map referencing, remember the map reference that you're given at the top, it says an extract of, let's say, 2831 dB. So that's basically what I was talking about. How do you find the direction, okay, the map that is maybe west of the given map or something like that? I think I've done that in detail. If you can just refer back to what I've said previously. Okay, the grid reference, obviously, we know the grid reference from the previous grades from primary is being done in alphanumeric, like the way we say now at this level, we are saying block C4. We used to call that, that's also grid reference, but it's in alphanumeric. But here, when you talk about grid reference, it's part of spatial data, we are using coordinates, or it's geo-referenced. So it means we are looking at 33 degrees, 22 minutes, 18 minutes south, 18 seconds south, 18 degrees, 34 minutes, 42 seconds east. That's part of your coordinates, which is part of how the features are geo-referenced on a map. That's part of your grid reference that you use. Then cross-section. Obviously, we are looking at the rise and fall of the topography on a map, or of the landscape on a map, which is shown more like a side view from one point to another. That's part of your cross-section. So you should be able to do a simple cross-section, but obviously you make use of the height in order for you to do the cross-section. Then intervisibility. What we are simply saying is, when you are looking at considering two given points, are you able to see clearly the point from one point to another? Is there any obstruction? Which means if there are no obstruction, there is intervisibility. If there are obstruction, there is no intervisibility. That's basically what we are talking about. Then direction of river flow. I've talked about how we can come up with the direction of river flow. The number one, look at your dam hole. The river will flow towards the dam hole. Number one. Number two, look at the angle at which the small tributaries are joining the main river. If they're joining at acute angle, they also help you to know the direction in which the river is flowing. Look at also your contour height. Of course, it helps you, because when you're looking at the longitudinal profile of a river, we say that it flows from the upper course to the lower course, of which our upper course obviously is from a higher land towards the lower course, which is a lower land. Remember, there's more erosion in the upper course, which means it's steeper. And there's more deposition in the lower course, which means it's gentle. So obviously, we are saying that it flows from a higher lane to a lower lane. Look at the contour height. It helps you also in knowing the direction in which the river is flowing. The other way that you can do as well is that your dam hole. The river will always flow towards the dam hole, not away from the dam hole. This is your dam hole. Okay, the river will flow towards the dam hole. That's basically what you're saying. In some instances, you can also check how the name of the river is written. Maybe it's Orange River. Of course, it also helps you to know the direction in which the river is flowing. But please, you have to make sure that you try all this in order to make sure that you have got the correct answer. Then the other thing that we also talked about was the direction. I have demonstrated the 4 cardinal points, that is your north, south, west, east. I've also demonstrated the 8 cardinal points. I've also demonstrated the 16 cardinal points as well. So you can use all that in order for you to know how to do your cardinal points or direction. I always do, I just do this just to, okay? Remember, east is always on your right and west is always on your left. I always use it's never, ever smoke weed. Never ever smoke weed. That is your 4 cardinal point. North, south, east, west. Never ever smoke weed. That is your 4 cardinal points. North, east, south, west. So remember, east is always on your right and west is always on your left. You can do your 8. You can move on to do your 16 cardinal points. I think we have talked about that. I also demonstrated that. Then your bearing, we are talking about your true bearing. We're talking about your magnetic declination. We are also talking about your magnetic bearing. So all in all, this, you must be able to do these math skills in order to answer your question 3. You must be able to have the skills of how to determine your height, your map reference, your grid reference, your cross section, your intervisibility, direction of the river flow, and direction of bearing. These are the 7 basic skills that you need in order to answer your question number 3. Obviously, not forgetting the GIS, of which we have already talked about as well. Ta-da! Thank you.